Then you have variables, right? Variables are the characteristics or conditions that are manipulated, controlled, or observed by the experimenter. So these are the things that we study, right? These are the concepts that are put together, and we try and study whether one is related to the other, one causes the other, one doesn't cause the other. If there is 3 4 involved in between this relationship, are these 3 4 things linked, etc., etc., right? So these are variables. uh, Variables are like another definition is variable is anything that varies. I have never understood that definition. Everything varies, right? Variable is a concept, right? Think of it like that. It's a concept that you're trying to test, and you're trying to test it in multiple ways. Sometimes you're trying to test it in terms of relationships. Sometimes you're testing it in terms of controlling one variable. You're sometimes testing it in terms of causality and XYZ, right? There are two types majorly. There are other types also, but majorly there are two types. There is the dependent variable, where the experimenter makes a prediction, and sometimes usually it's said that this is the not manipulated variable. And then there's an independent variable, which is also known as the stimulus variable, which is also sometimes called the active variable, which is the variable that the experimenter manipulates, right? Or selects or measures for the purpose of producing observable change in the dependent variable. Now, this thing, independent and dependent variable, is primarily linked with the experimental method. Okay, so in the experimental method, you have the independent variable because it's manipulating the dependent variable, right? You're manipulating something here and trying to see whether that's causing change here. If there is change, then you're saying this change causes this change, right? That's the fundamental basis of the experimental method. And then you control 10,000 different variables in between, right? So that you can zone in that this is the reason. So you have an independent and dependent variable when you're doing the experimental study, any kind, right? But when you do other forms of study, if you're doing, say, a correlational research, then you don't have an independent and dependent variable because neither are being manipulated by you. You're simply seeing how many people feel this way, for how much, and what is the range, what is the pattern, how many people feel for this thing, and then you try and find a pattern between the two, right? Whether they are linked or not. So you're not manipulating anything. At that point, both variables are just independent variables, right? Because none is affecting the other. When you do an experiment, that's when this independent dependent thing comes in. Or when you do like a regression study, then you have a predictor variable and an outcome variable, right? But independent variable and dependent variable primarily limited to experimental method. Now there are two types within independent variable. There is type E, that is a variable that you're directly manipulating. Type S, that is a variable you're manipulating through selection, right? So say for example, you want to see the effect of student class on, like, which class they are in, on motivation. Okay, now if you take class 12 and you see their effect on motivation or whatever, right, and you create an experimental scenario, so you're only manipulating class 12 male and female, right? In that sense, it's an experimental directly manipulated. So they're directly manipulating males and females in class 12. Okay. Sometimes you might do an experiment saying who has more intrinsic motivation, class 12 or class 11, right? So you do this, you find the causality, and later when you're doing analysis, you also see that there might be a gender difference, right? So that's a type S variable. Gender then becomes a type S variable where it's manipulated through selection. That is, you are not directly manipulating it, but the circumstance of the experiment was such that it got manipulated, right? So it gave you a deeper understanding per gender, which you're not looking for, but you found it, right? So that's a type S form of independent variable. Type E is something that you directly manipulate. So class 11 and 12, if you're trying to see the effect on student engagement, for instance, right, then that's a direct manipulation. In that, if you start looking for gender difference, age difference, uh, socioeconomic background difference, then that's a type S form of independent variable. Okay. Then there's qualitative variable, quantitative variable. This is simple enough, right? Qualitative variables are things that you cannot order in terms of magnitude, as which is better, which is worse, or in terms of numbers, right? Saying that 1 is this, 2 is this, 3 is this, or 1.1 is this, 2.2 is this, 2.1.678 is this, right? That is not possible. So say for example, something like stereotype, right? You can't have a numerical term explaining how stereotype does person X feel about member Y, right? Although there are questionnaires available, right? It's still, now those questionnaires have converted this qualitative concept into a quantitative one, okay? But both things can exist, right? It depends on you as the experimenter, whether you look at whether you operationally define stereotyping as qualitative, or are you saying this is something that can be explained numerically, right? And according to that operational definition, the characteristic of the variable will change. Either it will be looked at in a qualitative way or in a quantitative way, right? So in qualitative research, for instance, you can look for, say, uh, the idea of the mind, right? You can discuss with people, you can go and interview people, what do you think about the mind, where in your life do you think mind is applicable, and XYZ, and you can have like a whole questionnaire where lots of people answer about what they think of the mind, and then you collate all of that and you see, okay, this is what majorly people think of the mind as, right? So it's not in numerical terms, because you can't have a question saying, hey, what do you think about the mind, is it satisfied, not satisfied, or whatever, right? You can't do that. So that's a qualitative concept, and it cannot be divided into numerical terms. Whereas in a quantitative setup, everything can be categorized in terms of magnitude, and it can be precise in terms of its measurement, right? So height, weight, whatever else. Now within quantitative variables, there are two types. There is the continuous variable, where you can have numbers that are in arbitrary degree of fineness. So you can have like an exact number, say someone's height, right? You can have 171.56 to 13675, whatever, it can go until infinity, right? So that's an exact degree of fineness. You can know exactly what someone's height is, right? So 161.3, 166.312, and it will end like that's their height, full precise till the end, inch if you want, or centimeter, you can find exact, right? Weight also like that. Marks in an exam to an extent, right, depending on how the teacher corrects, but you can get a degree of fineness there also. Then there are, so that's a continuous variable, meaning that from 1 to 10, if the numbers are those small bits between 1 to 2 are also possible, right? Now it need not be always that it has to be 1, 1.1, 1.111, 1.112, not necessarily that degree of fineness, but there is an exactness that can be measured. So you can have like an exact height, an exact weight, an exact mark in an exam, exact percentage, right? It need not be that fine all the time, but there is an exact number, like this is it. Whereas a discrete variable, there is a gap between things, but there is no fineness. So you can have someone in class 1, someone in class 2, class 3, but you can't have somebody like who's a little more class 1 and a little less class 2 and a little more class 3. Someone can't be in class 2.2. All that can't happen. However, there is a numerical term, numerical number associated, right? In terms of gender, it's not number, but there is differences. So there is male, female, transgender, and queer, and whatever else, and whatever different genders that people think, right? So again, it's not exact, like I'm not like I'm completely male or I'm completely female, not like that, right? But there's a categorization in terms of a category, that okay, male, then there is a separation female, then there is a separation transgender, right? In sex, male, female, based on anatomy, right? So these are called discrete or categorical variables, where you can't have exact degree of fineness, right? You can't have exact male, exact female, you can't have, but there is still categories, right? And these categories are generally accepted in the world. Whereas in the qualitative framework, say we are talking about stereotypes, right? There is no, okay, less stereotype guy, more stereotype person. There is no law, there is no calculation for that across the world, right? So that becomes qualitative, it becomes in its own space, right? Whereas in the quantitative realm, there is continuous variables which can be marked in terms of exactness or fineness, and there is categorical variable, which there are categories which are well defined basically, right? And then there is a range within that, but these categories are well defined. This is very important to understand, because from a statistical point of view, this will come back, right? There will be certain kinds of correlations that you can do only if it's categorical. There's certain types of correlation you can only do if there is continuous, and that sort of thing, right? So it will come back. So just please get this clear in your head. Then there are mediating, moderating variables, right? A mediating variable is one where the mediating variable itself is affected by the independent variable, right? So think of it like a diagram. Independent variable affects mediating variable. Mediating variable affects the dependent variable, okay? And the independent variable affects the dependent variable also. So it's like a triangle, right? So the mediating variable comes in between this relationship, right? So say you're saying, take this example only, like playing basketball and attention. So you play basketball, attention improves. So independent variable, playing basketball manipulated, and it's affecting attention levels, right? Suppose you found that, okay, playing basketball is related to increase in attention levels, right? And then you do some more literature review and you find that, oh, the kind of food, right, is affected by the amount you play. Like the amount you play affects the amount of food you eat, and the amount of food you eat seems to affect attention levels, right? Which means the amount of food can affect this relationship between A and B, right? So then you create a mediating model, and you calculate the kind of food somebody has eaten or the amount of food somebody has eaten, and then you run a mediating analysis, right? When you do the mediating analysis, what you will find is you'll find one relationship between A and B, that is playing basketball and attention. You'll find the relationship between playing basketball and eating food, right? You'll find the relationship between eating food and attention. And when you subtract this relationship from this direct relationship, so this is called the indirect effect and this is called the direct effect, right? From A to B is considered the direct effect. A to B through C is considered the indirect effect, right? When you remove the indirect effect, then you will know the actual relationship between A and B, right? So if you remove the food and if you make the food consistent for every participant for all those days, right, then you have gotten rid of the mediating variable, the variable that's affecting this relationship, right? And then you can actually see what the true relationship between basketball and attention is when food habits are consistent, right? So that's basically a mediator, right? A mediator variable affects the relationship between the independent and the dependent variable, right? Sometimes you can calculate it as a model, or what generally people do when they're doing an experiment is they try and control the mediators as much as possible, right? A moderating variable, on the other hand, is a variable that affects the dependent variable but does not interact with the relationship or the independent variable. So it's a so for example, in this case, there's basketball and attention, right? You have removed the mediator, so now you know the exact relationship between basketball and attention. But then you read more literature and you find that attention is also affected by, say, intelligence level. Okay, no, intelligence is bad example. Suppose attention is also affected by empathy. Okay, suppose you find that attention is also affected by empathy. So, and then you read some more and you find no relationship existing between playing basketball and empathy, right? Suppose. So then that's the moderating variable, meaning that it's affecting the dependent variable, it's affecting attention, right? Irrespective of basketball existing or not. So when basketball and attention are being linked and a relationship is being found, you can't still be sure how much of it is attention is being affected by just basketball, because you know it's also being affected by empathy levels. So then you try and you create a model and you statistically test how much is attention affecting this relationship, or if you're doing an experiment, you try and control the empathy levels and then you do a causality. Now there are different types of reliability. The first and the most often used one is test retest reliability, right? This is where you test the same test over two different time points, right? So the same test is given twice and then you find the correlation of scores, and then if you give it to 100 people, you'll find 100 score, like you'll find 100 scores for time A, 100 scores for time B, and then you correlate how often are they scoring similarly, right? If they score similarly a lot of times, that means there is high reliability because there is high consistency of scores, right? If your correlation scores are low, it means that they are not scoring similarly over time, right? Which means that the reliability drops, right? Usually the interval between the two time points is 15 days. The result that you find is known as the temporal stability coefficient. Very important, mark this up, okay? TSC. So In test retest reliability, that is TRR, that is test retest reliability, you get the temporal stability coefficient as the correlation name, right? It's good for both speed based tests and power based tests. We'll come to what speed and power based tests is at a different point in time, but remember that it's good for both, right? Speed test is basically how quickly can somebody answer based on a certain time point, and power test is there is no time limit and you have to answer only correctly, right, as much as you can. In a test retest reliability, the only source of error variance is time. That is, people will have errors in their score based on the time difference, right? So some people in 15 days they might still recall the first time they gave the particular test and begin an answer similarly. Some people might forget, so they'll answer completely differently. In those 15 days time period, a lot of stuff could have happened to a person and that might have altered their worldview. So again, there might be a difference. So the source of error variance in test retest reliability is based just on time sampling. Okay. Then you have alternate form reliability. This is where you find a similar test like the one that you have created or the one you're using, and you try and find a correlation between that. So you take the, say, introversion extroversion questionnaire by Ising, and you take the Costa and McRae's open, that ocean model, right, and you try and figure out the correlation between the extraversion scores between the two. Only extraversion, forget the rest of it, right? So there are two similar tests, two tests that are assessing the same thing, that is introversion, extroversion. Different kinds of questions are there, but they're assessing the same thing. So you give person A Ising's questionnaire, you give person A the ocean questionnaire, right? And then you give that to 100 people and then you see their scores and you see whether in both the tests are they getting similar scores of extroversion, right? Is extroversion high or low in both the tests, or are they getting inconsistent scores across them, right? So if the scores are similar, it's an indication that high correlation is there. If the scores are inconsistent, if the scores are consistent, it means high correlation. If the scores are inconsistent, it means low correlation, meaning reliability is low or high, right? Now interval is important here also. You don't give it at the same time because questions might be similar, right? More time and different tests reduces coaching or teaching effects, right? So because you've given one, you learned how it works and you might do the same second one similarly. So you give time and difference in the kind of tests, right? So one test might be a dichotomous test, yes or no. Another test may be a multiple choice one, right? So you give different tests and you give space between the tests, right? The result here will be called the coefficient of equivalence. The source of error variance here is again based on time, because the amount of time will affect recallability and reliability of ability. And the other one is the kind of content there is, right? If the two are very close, very similar, then that might create error. If they're too far apart also, it might create error. So the content between the two needs to be just right, right? So that's another form of error variance that might exist in the alternate form reliability. Then the third is known as the split half reliability, right? This is also known as the coefficient of internal consistency, because what you're essentially doing is you're taking one test, dividing it into half, and you take the odd questions and even questions and correlate the scores of the same test to see whether there is similar answers that people are giving, right? So usually people do odd even, but sometimes they also split it in half, right? So they'll top 50 and bottom 50. That depends on how the questionnaire is structured, but you're again trying to find how reliable are the scores in the same questionnaire, right? Naturally, if the test is longer, there is going to be higher reliability because there are more questions that are being asked. Therefore, there are more assessments that can be done, right? So if you have like a 10 question and you do split half 5-5, again there are less questions and each change will affect the overall score to a great degree. So for example, if you have 5 questions odd and 5 even, right? If 4 of them are similar and 1 of them is not similar, that's 80% similarity, right? But if 2 of them are similar and 3 of them are not similar, then that's 60% of non-similarity, right? Which is a huge degree. There's a 20% degree of difference per question, right? So that's going to impact your reliability scores to a great degree. Whereas if you have a question that's 100 items, then each item is going to affect your reliability by barely 5%, right? Actually 101%, right? Each thing will affect it only by 1%. So the longer it is, the better the reliability will be. Now in the split half reliability, there will always be the Spearman, like usually the Spearman-Brown formula is used to test the coefficient, right? So that's the basic formula that is used to find the split half reliability. So for the other two, you use traditional correlation, okay, Spearman's correlation for these two. But over here, you use the Spearman-Brown formula, okay, to find the reliability based on the changing text length. However, now we've started to use a tau equivalent reliability, which is also sometimes referred to as Cronbach's alpha, right? Now the source of error variance here again is content. Content meaning because you are assessing it at the same time point, you can't have time based error. So you have it in terms of what the content is, right? On the closeness of the two, right? If suppose you've created a questionnaire where top 50 is easy questions and bottom 50 is difficult questions, and then you try and find the reliability, you will not find it, obviously, because there is a difference in terms of the difficulty level, right? But in this kind of case, if you take odd even, odd even, odd even, then there is a higher likelihood of the reliability being slightly higher, right? So the content is important in terms of the errors that you might find. Then you have the Kuder-Richardson method of finding reliability, right? Now the important thing is that in split half and Kuder-Richardson, both are done as single administration. So in all types, in your test retest, it's done at 2 time points. Alternate form 2 time points. Split half once. Kuder-Richardson also once. So there is a single administration to find the reliability. Performance is rising in each item means that in each item it gets slightly more difficult. If that is the kind of test you have, then Kuder-Richardson fits in well. It can also be used for yes no items, which is where you use the KR20 formula. So Kuder-Richardson took out an entire book of basically formulas of how to find reliability. The 20th one is called KR20. That 20th one is applicable for yes or no type of questions. Okay. And it's most optimum if it's yes or no. The most optimum number of items that you should have in your test is 120 items. For multiple choice, if you're using Kuder-Richardson, then you will use the same thing. That is the tau equivalent reliability or the Cronbach alpha. For net purposes, this is important, okay? For yes or no items, KR20. For multiple choice, coefficient alpha. If the entire questionnaire has homogeneous items, right? If the entire thing is assessing, say, personality only, right? If that's all your questionnaire is doing, in that case, split half is better than Kuder-Richardson. Okay, but if you have heterogeneous items, so one part of it assesses emotional intelligence, another part of it assesses motor flexibility, another part of it assesses empathy, right? If that's the way your questionnaire is structured, then the Kuder-Richardson method is a better form of finding reliability, right? So please remember this, okay? When there are homogeneous items present, the split half reliability is better when you're doing single administration. But you have heterogeneous items, then the Kuder-Richardson is better, right? Now, KR underestimates the coefficient source, meaning it underestimates the errors in general, right? And the source of error variance for Kuder-Richardson is again based on content, which is again based on what are the items in the scale, right? Then you have the interscorer reliability. This is not technically numerical. It's based on how there are other scorers, how they review the test, right? So you might have created one questionnaire, someone else might have created another questionnaire, or you might have created one and I know another one, right? And I'll score it. Basically, I will not give the test and I'll score what might be the reliability, whether these questions make sense or not, right? So 2 or more scorers review the same test. So me and you take another 2-3 faculties and they'll see the test and they'll say, okay, this is a good question, bad question, good question, bad question. And then you see across the 3 which are the ones they've said is good, which are the ones they've said bad, and the bad ones you sort of improve, right? This is usual. This is again, coefficient is calculated correlation, and it's useful for subjective tests, meaning that if you're asking, say, case study based questions in your questionnaire, then interscorer reliability is much better. Does that affect reliability, right? There is variability. meaning that when you test 1,000 people, you should get a range of scores, right? You should get a range of scores from someone scoring very low to people scoring very high, right? So if the variability is more, the reliability is more, right? Because everybody is sort of scoring throughout the entire scope, right? Now this variability is not in the same person, okay? Like the same person should score consistently, but the entire sample should score as a range, right? The entire variation of score should be there. Then in terms of the number of items, if you have more questions, reliability will naturally be higher because each item cannot skew the reliability numbers, right? Then item difficulty, that means how difficult is it to answer a particular item, right? If it's moderate difficult, it leads to higher reliability. Obviously, if it's too difficult, then not a lot of people are getting it right, so the reliability will drop. If it's too easy, then a lot of people are getting it right, which means reliability will be very high, right? So if you want a decent reliability score, then moderate difficult questions should be asked. If the questions are similar, the more homogeneous they are, the higher the reliability score naturally, right? Because similarly only someone will answer. Then the scale format or number of response options, if there are more, then reliability is high. So again, if you have only a yes no questionnaire, then the reliability of that will be naturally lower than if you have a Likert scale based questionnaire, because again there is a range of scores that you're getting, right? And yes and no, each of the thing will skew the score exponentially 50%, right? Whereas a Likert scale will not. And last thing is just remember this, right? Test retest, the error variance is time sampling, alternate form content sampling, alternate form delayed time sampling and content sampling, right? Alternate form immediate means at the same time point you give both the tests, which is not advisable. Alternate form delayed is where you give it at two different time points. Split half content sampling, Kuder-Richardson and coefficient alpha content sampling and content heterogeneity, and scorer interscorer differences naturally are the form of error. The next big concept is of validity, right? This is again something that all of you are probably familiar with. Validity is basically if the test is measuring what it's claiming to measure, right? If the test is for personality, is it actually testing personality or is it testing emotional intelligence, right? So how well does a test measure what it's supposed to measure? Now there are different types. There's content validity, right? Which is in terms of the content of the questionnaire, right? Are all the items in the questionnaire attempt measuring what the test is meant for, right? So if each of the items are fitting into that dimension, right? Now the objectives need to be broad for this to happen. It's not good for aptitude or personality tasks, right? Not tests. So for aptitude, you need a variety of questions. So in that case, if your content is targeted towards only one type of goal, then it's not a great kind of validity measure to have, right? Because aptitudes are so varying that you need to have broad-minded questionnaires for them, right? It needs to be intrinsic, meaning that internally it needs to be valid, right? It needs to be relevant. It needs to be circular, meaning each of the items must link with another item, and it must represent the actual context that you're trying to sort of study, right? It requires both item and sampling validity. Item and sampling validity, meaning that the items need to be valid as well as the population that it is meant for. It should be valid for them also, right? So you can't create an intelligence test and say this is for old people, but it doesn't fit old people, right? Then that doesn't work. So these are two important criteria that are necessary, right? Then you have face validity, which is the appearance of the test, whether it looks like it's supposed to measure whatever it's supposed to measure, right? So if you have like an intelligence test, but it's a questionnaire, then it doesn't fit that well as face validity, right? Like you're like, oh, I'm not sure this works. Or if you have like a measure for extraversion and introversion, and then you give them like tasks to do, like how you do for intelligence test, right? Then also it doesn't fit. Then you're confused, like this face validity doesn't exist. So face validity is important from that point of view, that when you tell somebody this test is for this, they should see the questionnaire and whatever equipment that they're using, and she should be able to be like, yeah, okay, this makes sense. This probably is for that, right? Then the interesting kind of validity is criterion related validity. This is the kind of validity which sort of tests someone's performance on a particular criteria, right? In terms of predicting. So say in a very broad sense, exams are tests that are created for criterion related validity. Basically, the idea is what somebody who does well in an exam is much better prepared to go to the next class, right? or is much better to be more successful in life or whatever. That's the larger idea, right? So in a way, exams are that they are criterion related validity. They have criterion related validity, right? Is the ability to predict an individual's performance. So how somebody does on a particular test will be able to tell you how they're going to be next time, right? So in this, sometimes there are already criteria available to measure the future prediction, right? So say for instance, you're in class 8, right? And you're doing math, and suppose you're in class 10 and you're doing math, okay? And then there's class 11 math, right? There's a whole difference, world of difference between class 10 and class 11 math. Now, if you do well in class 10 math, right? What is the prediction that you'll do well in class 11th math also, right? And for that, there are already questions available. There are already criteria available of what means that you'll do well here, right? So that's a concurrent criterion related validity where the performance here can be assessed in the future because there's already a criteria available for testing in the future also. Okay. So in this case, the validity has both sides fixed, basically. Like what you do today will affect you, will sort of give me an idea of how you'll do tomorrow. And tomorrow I can test you. There's already available tests there, right? And therefore I can see a comparison between these two validities, right? Whereas predictive validity is slightly different, saying that I will test you now and I'll make a prediction of how you'll do in the future. But there is no test available right now in the future that's going to give me a comparison, but it will be available. So I'm making a sort of guesswork, saying that it will be available in the future for me to make that decision, right? And usually it's the same author that makes the next questionnaire or next experiment or next task or whatever, right? But that's predictive criterion related validity. So concurrent is where I test you now, right? The test measures what it's supposed to measure now and makes a prediction about how the person who gives the test will perform in the future. And in the future, the test to measure that is already available. Okay. In predictive validity, that's not the case. You're tested now, and then in the future, you're hoping that the test will be available. So you're making a prediction that the performance can be reviewed in the future by another test that is not created yet, right? So obviously, naturally, predictive validity is not as good as concurrent validity because it involves sort of throwing an arrow in the dark, right? Saying the hoping, it's based out of hope more than an existing construct. So that's one important difference that you should know, right? Then you have construct validity. This is also known as factorial or test validity. This is the entire construction of the test in terms of how relevant is the test, how valid is the test to measure a theoretical construct or a trait. So there is one idea that it should be able to measure. So in content validity, right, it should be able to measure, the item should be able to measure the objective of the test, right? Here, it's beyond the objective also. It needs to be able to understand an entire theoretical construct. So when, say, for example, Myers-Briggs made their personality questionnaire, right? The objective was to analyze personality, right? But it was to analyze personality from the Jungian framework of personality description, right? So how well is it doing that? That's construct validity. Now there are two types. One is convergent, that is that this test should be similar to other tests that are testing for the same construct. And there's divergent, saying that this test should not correlate with unrelated tests, right? So convergent is that tests that I have created should match with other tests that are created assessing the same theory, right? Whereas divergent is that my test should not correlate with other unrelated stuff. So if I made a test for personality, it should not correlate with personality questionnaire and some other random emotional intelligence questionnaire or maturity questionnaire or something like that, right? So two types, two ways people can work. Usually they do use the convergent method because the divergent measure method essentially, or what you're doing is you're saying that my test is valid for this concept. And then if I say it's not valid for other stuff, and if it cannot get correlated with other stuff, then what I'm essentially saying is that you can't use this test for other research purposes, right? Which is sort of unfair. So that's basically why convergent tests are used, right? Mixing the two creates a multi-trait, multi-method matrix, right? Just mark that up. There's no need to know what it is.